Electromagnetic spectrum. What is light really? Well, light waves are three-dimensional and they vibrate in all planes around the center line. The waves have high points called crests. Waves also have low points called troughs. The distance between one crest and to the next crest is called a wavelength. The number of waves passing a given point in 1 second is called its frequency. So when electrons in a material vibrate, they emit energy in forms of photons, which propagate across the universe. Photons are nothing other than light. Photons have no mass, but are pure energy. Electromagnetic waves are waves that are made up of photons, where each photon travels in a wave-like pattern, moving at the speed of light, and carry the same amount of energy. The difference between radio waves, visible light, gamma rays, and the amount of energy is the amount of energy of the photon. Radio waves have photons with low energies, microwaves have more energy than radio waves, gamma rays and cosmic rays have high energies and are the deadliest. So this is what an electromagnetic spectrum looks like. So starting from very, very short wavelengths to very, very long wavelengths, this is kind of where we all fall. Okay, so if you were to look at what the wavelength meters would be of, say, a baseball versus a cell versus bacteria, viruses, and so on. Wavelengths and frequencies are connected together by speed. So if you were to look at this slide, as you increase the wavelength, you decrease the energy. So as the frequency goes up, the energy goes up, and the wavelength goes down. The only small part of this spectrum that is visible to us falls right here, which is called the visible spectrum. Anything beyond that is called either ultraviolet or infrared. Microwaves, like the ones that you use in your microwave every day to heat up stuff, fall somewhere here, whereas radio waves have less high frequency, and X-rays and gamma rays go towards more energy. So the different types of electromagnetic radiations are talked about here. They go from light rays, infrared, microwaves, radio, ultraviolet, X-rays, and gamma rays. And we will talk about them in a little bit more detail. So light is an electromagnetic radiation of wavelength that is visible to the human eye, which is about 400 to 700 nanometers. Infrared is the human body's in sort of like in thermal light. Microwaves are electromagnetic waves with wavelengths ranging from 1 meter to 1 millimeter short and frequencies between 0.3 to 300 gigahertz. Radio waves are electromagnetic, again, with wavelengths longer than infrared light, naturally occurring, and they are produced by lightning or by astronomical objects. Artificially generated radio waves are used for broadcasting, mobile, fixed communication, navigations, computer networks, and other applications. Ultraviolet light is electromagnetic radiation with a wavelength shorter than that of the visible light but longer than X-rays, in the range from about 10 to 400 nanometers, and energies between 3 and 124 electron volts. X-rays, we've all had X-rays done before. They are also electromagnetic radiation with wavelengths in the range of 10 to 0.01 nanometers and higher frequency range, about 10 to the 16 hertz to about 10 to the 19 hertz. Gamma rays are the deadliest of all of these rays. These are high frequencies, high energy, very short wavelengths. They are produced by subatomic particle interactions such as electron-positron annihilation, pion decay, radioactive decay, fusion, fission. Gamma rays have frequencies greater than 10 to the 19 hertz, and they have very, very high energy.